Yes, welcome to class. So, hello everyone. So, in this class, we will discuss about the important topic and important chapter trigonometry. So, it's very important chapter for every student, up to especially in the intermediate plus one plus two, and for any competitive exam they will ask from this chapter. So, in this one, we have to discuss about the from basic concept. So, first of all, introduction in this one. How can you define the trigonometry? Now, if you see that word trigonometry, 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 trigonometry. So, this word we can divide into three different words like that means three parts. Trigonometry. Tri means three, gona means sides or angles here, and metry means measurement. Metry means measurement. That means the measuring of three sides of the right angle triangle. The measuring of the three sides, or in other words, trigonometry is studied about the ratio of the sides of the right angle triangle. Ratio of the sides of the right angled triangle. Right angled triangle. Okay. So trigonometry is the studied or deals with the ratio of the sides of the right angle triangle. We know already ratio. Ratio means comparison of two quantities of the same units is called ratio. And how can you say, how can you define the ratio of the sides in the right angle triangle? Means before that, here right angle is there. Right angle means we know already. Right angle means how much? 90 degrees. So right angle triangle. That means in a triangle, any one angle is 90 degrees, then it is called as a right angle triangle. See, maximum students or maximum persons, they don't know how to. That means why we are using the right angle triangle only in the trigonometry. For that, so many reasons are there. So, in my point of view, I am saying this one. See, for example, this is the Earth. AB is the base. That means Earth. So, if we stand here, if we stand here, assume AC. AC is the height of the person. So the height of the person always makes 90 degrees with the base. That means it should be always vertical to the base value. The person is always, not only person, is there an electric pole or any one tree or any one building. These are always makes exactly vertical to the base value. That means it always makes 90 degrees. And if we draw this one CB, here one triangle formed here. Which type of triangle? This one, right angle triangle. So in this right angle triangle, so here angle A value 90 degrees, and so to this 90 degrees, here one opposite side is there. What is that? CB. So this CB is called as the hypotenuse. So the side which is opposite to 90 degrees, the side which is opposite to 90 degrees is called as the hypotenuse. So in the right angle triangle, we should always use the hypotenuse value. Hypotenuse. So hypotenuse will exist in the right angle triangle. It is also one of the point to use the right angle triangle in the trigonometry. And especially trigonometry applications are nothing but to find the heights of the building, or to find the depth of the oceans, or you can find the height of the trees or height of the electric poles. So those are always makes 90 degrees with the base value only. So in that point we can use the right angle triangle in the trigonometry chapter. Okay, coming to the point. So in this right angle triangle, here in that ABC, A is the 90 degrees. Already we know that sum of three angles of triangle is 180 degrees. Sum of three angles of triangle by the angle sum property. That means angle A plus angle B plus angle C value is always how much? 90 degrees. But in that three angles, one angle we know already here, 90 degrees. So sum of the remaining two angles, that means angle B plus angle C value is always 90 degrees. Because of in the right angle triangle, one angle is already fixed at 90 degrees. So sum of remaining two angles is equal to how much? 90 degrees. So we know that sum of any two angles is 90 degrees. Those two angles are called complementary angles. Those are called what? Complementary angles. Sum of any two angles is 90 degrees. Those two angles are called what? Complementary angles. So in the right angle triangle other than 90 degrees, the remaining two angles are called complementary angles because of their sum is how much? 90 degrees. Is it clear? Now, if you observe here, in the triangle, we should identify that opposite side and adjacent side. That is a very, very most important point. Then how we see that one? See, for example, if we take one triangle here, ABC, right angle triangle, ABC. So here B is equal to 90. So angle B is equal to 90. And the sum of remaining two angles is 90 degrees because of both are complementary angles. Now, I will take here at the point C, I will take one angle theta. So theta is a one Greek letter to represent angles. Okay, alpha, beta, gamma, delta, these are all the Greek letters. So theta is I am taking at the vertex C. Now if you observe here, for theta, what is the opposite side? For theta, opposite side is what here? AB. So for theta, opposite side, for theta opposite side is AB, theta opposite. Similarly, theta adjacent side, sorry, theta adjacent side is what? Theta adjacent, BC only. Theta adjacent side what? BC. Sir, theta adjacent side AC also is there now. But AC already it has some particular name is there. It is called as the hypotenuse. Don't consider it is the either opposite or adjacent. So in the three sides of the triangle, the side which is opposite 90 degrees hypotenuse. In the remaining two sides only, we should select the adjacent side and opposite side based on the theta value, based on the angle value. For example, if we take theta at the point A, at the point A if you take theta, for A what is the opposite side? BC is the opposite side. What is the adjacent side here? AB. AB is the adjacent side for A, angle A. So AB is the opposite side for angle C. BC is the adjacent side for angle C. Is it clear? So you should identify opposite side and adjacent side. So we know already hypotenuse which is 90 degrees opposite. Okay. So it is very, very important to find the opposite and adjacent. Why I am saying means, so in the next coming problems we should use this point, opposite side and adjacent side. Now coming to the point here. So I said ratio of the sides of the right angle triangle. For example, if you take one right angle triangle ABC, ABC, in that angle B is equal to 90 here. In that angle B is equal to 90. Now ratio of the sides, we can take any two sides ratio. That means I am taking here AB by BC, AB by BC, AB by BC. It is also one ratio. Similarly, AB by AC is also one ratio. So like that, total how many ratios we will get means total 6 ratios we get. Total 6 ratios. Wait, I will explain that one each and every one. See, compulsory I have to take something angle at any point either A or C. Now I have to consider the angle at the vertex C, theta. So at the vertex C I am taking the theta. Now there are 6 ratios are there. There are 6 ratios. That means because of we are getting the 6 ratio of the sides of the triangle. See, AB by BC 1 ratio, BC by AB reverse, AB by BC 1 ratio, BC by AB is second ratio. Like that we are getting total 6 ratios. Now see, first one AB by AC I am taking first ratio, AB by AC first ratio. Next one I am taking BC by AC, BC by AC, and next one I am taking AB by BC, AB by BC third ratio. Fourth ratio AC by AB, AC by AB. See, if you observe here, the fourth ratio is the reciprocal of first one. And next ratio is AC by BC. AC by BC. And next ratio is BC by AB. BC by AB. Now, if you observe here, AB is the theta opposite side. That means opposite side of theta. Understood now this one? So AB is the theta opposite side by AC is the what here? Hypotenuse. Is it clear? So AB is the theta opposite side and AC is the hypotenuse. Coming to the second one. BC. BC is the theta adjacent side. That means adjacent side of theta. Adjacent side of theta by AC is the hypotenuse. That is a fixed one. Hypotenuse. Now AB by BC. AB is the opposite side of theta. Opposite side of theta by BC is the adjacent side of theta. Adjacent side of theta. Now AC by AB. AC is the what? Hypotenuse by AB is the opposite side. AB is the opposite side of theta. Now coming to AC by BC. AC is the hypotenuse by BC is the theta adjacent. That means adjacent side of theta. Adjacent side of theta. Now BC by AB. BC is the adjacent side. Adjacent side of theta by AB. AB is the theta opposite. That means opposite side of theta. Opposite side of theta. Now coming to the ratios. So these 6 ratios we can call it each and every one some individual name. See, opposite side of theta by hypotenuse. That means theta opposite side to the hypotenuse is called sine ratio. Sine ratio, that is called sine theta. So sine theta we can define as opposite side by hypotenuse. Now adjacent side by hypotenuse is called it as cos theta, cosine ratio. Actually the full form is cosine ratio. Cosine theta, full form. This one is a sine theta, sine. They are the full forms, but shortly we can call it as a sine theta. This is a cosine theta. Cosine theta we can define adjacent side by hypotenuse. And the ratio of opposite side of theta to the adjacent side of theta we can call it as tangent theta. Tangent theta. Tangent theta. Simply we can call it as tan theta. Simply we are calling as tan theta. Okay. So tan theta formula what? Opposite side by adjacent side. And hypotenuse by opposite side. It is called as cosecant theta. It is called cosecant theta. Simply we are calling as cosecant theta. Cosecant theta. Full form cosecant theta. But simply we can write down like this. COSEC theta. Cosecant theta. Hypotenuse by adjacent. It is called secant theta. Secant theta, in simply we can write down in the short form secant theta like this. Okay, secant theta. And the ratio of adjacent side of theta to the opposite side of theta, it is called as cot theta. Cot theta, in full form cotangent theta. The full form is cotangent theta. Simply we are calling as cot theta. Okay, so these are the 6 ratios of the trigonometry. So it is a very basic concept, and these 6 ratios are very important to solve the next coming problems. See, sin theta formula what? Opposite side by hypotenuse. Cos theta formula adjacent side by hypotenuse. Tan theta opposite side of theta by adjacent side of theta. Cosecant theta hypotenuse by opposite side. secant theta, hypotenuse by adjacent side of theta. Cot theta, adjacent side of theta by opposite side of theta. If you observe here, this one, wait 1 second. If you observe here, fourth one, cosecant theta. Cosecant theta is the reciprocal of this one. Sin theta is what? Opposite by hypotenuse. Cosecant what? Hypotenuse by opposite. That means cosecant theta is the reciprocal of sin theta. Is it clear now? Cosecant theta is the reciprocal of sin theta. Observe that cos theta, adjacent side by hypotenuse. But secant theta is what? Hypotenuse by adjacent. But that means secant is the reciprocal of secant theta. Sorry, cos theta. Secant is the reciprocal of cos theta. Similarly, tan theta what? Opposite side by adjacent side. But cot theta what? Adjacent side by opposite side. That means it is the reciprocal of this one. So cot theta is the reciprocal of tan theta. Understood now? So if you know the first three ratios, the remaining three ratios are the reciprocals of the first three ratios. See how you can write on means that one. I will write here. So cosecant theta we can write on as 1 by sin theta. Okay, because of cosecant is the reciprocal of sin theta. Similarly, secant theta is also reciprocal of cos theta. That means 1 by cos theta. Secant theta. And cot theta, how can you write down? Cot theta is the reciprocal of tan. That means tan theta. Cot theta is the reciprocal of tan theta. So cosecant theta is equal to 1 by sin theta. Secant theta is equal to 1 by cos theta. Cot theta is equal to 1 by tan theta. So from this sin theta send this side. That means sin theta into cosecant theta. So if you send this value to this side, sin theta into cosecant theta is equal to how much here? 1. And from this also what you can write down? Send the cos theta denominator value to the LHS. Cos theta into secant theta is equal to how much you get? 1. And from this also tan theta send this side. Tan theta into cot theta is equal to what? 1. If you observe here, cosecant is the reciprocal of sin theta, na? Secant theta is the reciprocal of cos theta. Cot theta is the reciprocal of tan theta. That means if you multiplication of a number and its reciprocal is always how much? 1 only. The multiplication of number and its reciprocal is always 1 only. So remember these 3 points, very very important. Sin theta into cosecant theta value 1, cos theta into secant theta value 1, tan theta into cot theta value 1. So if you want to get the multiplication of these two values is equal to 1, compulsory the theta value must be same. Is it clear now? See, sin 30 degrees into cosecant 30 degrees. This value is only 1. Is it clear? Sin 30 degrees into cosecant 30 value 1, because of angles are same only here and both are reciprocal. So that's why their multiplication value is 1. For example, if the angles are not same, then that value is not equals to 1. Okay? Remember this point. And this cosecant theta, secant theta, cot theta are called reciprocal ratios. These are called reciprocal ratios. వీటిని reciprocal ratios అంటారు. And tan theta we can write down as sin theta by cos theta. See, tan theta how can you write down? Sin theta by cos theta. And also cot theta, how can you write down cot theta? Reciprocal of tan theta. No, do the reciprocal. Cos theta by sin theta. This one. So tan theta we can write as sin theta by cos theta, and cot theta we can write as cos theta by sin theta. So these two ratios are called tan and cot quotient ratios. These two are called quotient ratios. Okay. So tan theta and cot theta are called quotient ratios, and cosecant theta, secant theta, cot theta are called reciprocal ratios. So actually cot theta reciprocal ratio and also it is the quotient ratio. Okay. Next, Sir, why you have to use this one? What is the necessary this one? See, just I will say one example. See, in the examination they will give, if sin theta is equal to 3 by 4, sin theta is equal to 3 by 4, then find other ratios, then find other ratio values. Like this they will ask you. Sin theta is equal to 3 by 4, then find the other, sorry, 3 by 4, not 3 by 5, 3 by 5 here. So sin theta is equal to 3 by 5, then find the other trigonometric ratio values. So to simplify this one, compulsory we want that formulas value, that means cos theta adjacent by hypotenuse, like that. See, first you have to draw one diagram here. If you draw the diagram in this one, A, B, C. So theta, actually here B is equal to 90. Somewhere you can take theta either A or C. For example, if you take theta at the vertex C here, theta. See, they are given here. See, given that, given what? Sin theta is equal to 3 by 5. Sin theta value 3 by 5. Actually, what is the sin formula? Sin formula what? Opposite side by hypotenuse. This one only, na? Opposite side by hypotenuse. For which opposite side? Theta opposite. So, opposite side value is how much here? 3. Hypotenuse value here how much? 5. Just to compare the ratios. Opposite side value 3. Hypotenuse value 5. Now, you should find the BC value first. BC is the adjacent side. We want adjacent because of to write the cos theta value adjacent by hypotenuse. So, there we should want adjacent value. How can you find the adjacent value? By the Pythagoras theorem. You know Pythagoras theorem? Hypotenuse square is equal to, hypotenuse is what here? AC. Hypotenuse square is equal to side square plus side square. That means AB square plus BC square. Okay. AC square means what? 5 square is equal to AB square means 3 square and BC square. 5 square value 25. 3 square 9. Send this side. Minus 9 is equal to BC square. So 16 is equal to BC square. And BC is equal to root 16. Root 16 value how much? 4. So BC value 4. Now you know every 3 values. That means all 3 values of the right angle triangle ABC. Now write in the remaining values. So remaining ratios are what? Cos theta. Cos theta formula what? Adjacent side by hypotenuse. For theta adjacent value. Theta adjacent what here? 4. Hypotenuse value 5. That means 4 by 5 is the cos theta value. And find out the next tan theta value. Tan theta formula what? Opposite by adjacent. Opposite by adjacent. Theta opposite what here? 3. Theta adjacent what here? 4. So 3 by 4 is the tan theta value. Next, similarly find the cosecant theta. Already I told you, cosecant theta is the reciprocal of sin theta. That means cosecant theta we can write as 1 by sin theta. That means do the reciprocal of sin. Actually sin what? 3 by 5. Do the reciprocal. Means what? 5 by 3. Next, secant theta. Secant is the reciprocal of which one? Cos theta. That means secant theta we can write as 1 by cos theta. That means what is the reciprocal of cos theta? Cos theta value 4 by 5. Reciprocal 5 by 4. Next, last one. Cot theta. Cot is the reciprocal of tan. That means 1 by tan theta. That is equal to tan theta value 3 by 4. Reciprocal means what to get? 4 by 3. So like this, we should find out all trigonometric ratio values. If they give any one trigonometric ratio, we can find out all the trigonometric ratios. So in the next class, we have to discuss about the trigonometric values at some particular angles like 0. How can you find out sin 30, sin 45, cos 60? We can discuss the proof also. Okay? Yes, thank you.